So some different specs for a cam. So we've got kind of two basic specs we look at. One is our lift, so how far are we pushing that valve open? The other one is the duration, how long are we keeping that valve open for? With that, there's a bunch of different charts that can kind of show us what that information looks like. So we're just going to go through these really quickly because this isn't something you guys are going to deal with a lot directly in most cases. So this is a chart showing us our valve timing in terms of when our exhaust valves open and close and when our intake valves open and close. And it's showing us degrees of crankshaft rotation. When we're looking at valve duration, even though that's set by the cam, we measure degrees of crankshaft rotation. So every 180 degrees of crankshaft rotation, what's happening? Changes, right? We're going through a stroke. So every 180 degrees is one stroke of the engine. So if we look at this, let's start right here. From here to here, piston's moving down, we're in the intake stroke. But look at when that intake valve actually started to open. Started to open back here, right? So before the piston was ever coming down, the intake valve was opening up. So now by the time the piston started to move down, intake valve's open a decent amount, it continues to open, stays open. Now piston's all the way at the bottom, piston's gonna come back up, and what stroke are we going to next? Compression, right? During compression, you can see that intake valve is actually still open a little bit at first. So our valves don't really open and close at the true ends of the stroke like we typically think of them doing. So we go into compression, intake valve finally completely shut, so now we're really compressing the mixture. So here we're at top dead center of compression. What are we going to do next? Power. So we go back over here, we ignite the mixture, we start to make power. As that piston moves down, before it gets to the bottom, our exhaust valve starts to open. So now, by the time the piston's moving back up, the exhaust is fairly open. We push the exhaust gases out. And you can see we have this period here of what we call valve overlap. So intake and exhaust are open at the same time. And again, that creates that scavenging effect. So exhaust leaving helps to draw in intake air and fuel. Intake air and fuel helps to push the exhaust gases out. And that works better at higher RPM. So here we're looking at two lobes actually on the cam, one intake, one exhaust. And this angle they're showing us here is what we call our lobe separation angle. So just basically the angle between the center line of those lobes. That lobe separation angle will ultimately help to set our valve overlap. So how much overlap we have. Overlap is good for performance, not so good for emissions. Because if intake and exhaust are open at the same time, we have the potential that some of that raw air and fuel goes straight out the exhaust. This is another type of diagram for cam timing. This is basically showing you the same thing as that chart we just looked at a second ago, just in a different format. I'm not going to spend much time on this one with you guys because to me this type of diagram is always very confusing. It takes a little bit of looking at it to really figure out what's going on, and it's not something we normally use very much. So if it's something you guys are interested in more, I'll be happy to kind of show you one-on-one how this works, but it's just not something that most of you are going to deal with very much, so I'd rather not confuse any more than is necessary. And then this chart, kind of the same thing. This is showing you some different options as far as lobe separation angle, valve overlap, all that stuff, and some of the different effects of it. So in terms of cam design, we're not going to get real deep into all the specifics on lobe separation angle and all that. Because for most of our engines, if we're needing to replace the cam, we're just going to put in a stock replacement cam, right? If we're dealing with a performance engine, that's where we're going to get into this stuff more. But that all kind of depends on where we're going, because if this is an engine where we're dealing with smog checks, we're going to be pretty limited as far as what we can put in there for cams. It's got to be an emissions legal cam. If this is all on racing, then we have a lot more flexibility. And this is just basically another chart, and this is kind of the same way as our first one. Just rather than drawing little curves of the valves open and closing, it just basically lists when the valves open and close. But same information as that first chart we looked at. And again, you see your valve overlap period there as well. And this is basically just another version of that other chart we just saw.